Well, I was talking to Andrew Maynard earlier, and he was saying that he'd like to see some really audacious proposals. So I thought, well, what's more audacious? I'm going to propose to create an institute whose purpose is to actually create a shortcut to humanity-aligned superintelligence. And this is not to think about it, well, there'll be thinking involved. This is to start building it. In fact, we've already started building it. This is to ramp it up. Okay, so what is, yes, so I called it the SETI Institute. What does SETI mean? SETI is an acronym for Simulation-Enabled Cooperative Human Intelligence. It is also the romanization of a Japanese word, and I'm sure I'm massacring the pronunciation in Japanese, but it can be translated as world wisdom or worldly wisdom, and I really like that. But in full disclosure, I should mention that it also means dry in Italian and urine in Ukrainian, and hopefully those are less on target. Okay, so what is the basic idea? It is a very, very simple idea applied to a very complex system. The idea, so in control theory, there's a whole branch of engineering called controls engineering. It's taught in every engineering school everywhere. And there's a very classic, used to be considered a relatively advanced topic. I think it's now a very standard thing called model predictive control. And fundamentally, if you need to control a complex nonlinear system, you don't have a simple model, it's not linearized, you don't know what it is, you just have some general complex nonlinear system. If you can construct a sufficiently accurate predictive model of that system, you can use that model to try to run little simulations and figure out what controls should we apply to this system inside your control loop. So you can wrap a model-based predictive control loop around your system. Now you have to have an accurate enough model and it has to run fast enough. So there's efficiency, and if your system is changing, you have to cope with all that. So we've got a complex system because we're going to wrap that model-based predictive control loop around all of the Earth's biosphere, everything happening inside the Earth's biosphere, including all human activities, and their interactions with the natural world, all the cyber-physical systems, and everything that affects it, like space weather, geology, everything. So, big model. And we're going to drive that model. The control signal that we're going to use is we're going to collect the preferences in the forms of preference models via the active cooperation of many, many people, hopefully all people, basically telling us what they want. And we're going to filter this in the form, through cooperative game theory and distributed model-based control, there's natural ways to do this, but fundamentally we're going to give each person participating in this, we're going to help them use whatever optionality they have initially. So we're not changing the power balance. We're helping them use whatever ability they have in a more optional way. Now, depending upon how we get to do this, there are some places I might like to put my thumb on the scale and cause bad actors not to be able to do it, but it might be a better net thing to have it available everywhere than not. So there's some political guesswork involved in how we deploy this. Why should we expect this to work? Model predictive control works. It's well known, it's established, provided you've got a good enough, efficient enough model. Number two, there are plenty of excellent research results from cooperative game theory and distributed model predictive control that says you can obtain nearly optimal behavior in the sense of avoiding multipolar traps, finding omni-win-win opportunities, just through this very simple thing, very simple conceptual approach, if your model is good enough. To make this work, we need to construct and maintain a sufficiently accurate causal model of the entire world. Small ask there. The good thing is, I see I edited and made this slightly wrong now, or not incomplete. So we need, to build those models, we need 1 minute? Oh my gosh. Well, for those that are interested, I have live demos of all kinds of stuff. Wow, that goes fast. Why has this not been done before? Because until quite recently, the enabling technologies we needed didn't exist. So when railroading time comes, you can railroad, but not before. There's one missing technology right now. All the others exist in some form close to what we need. We are building that last one. Done.
Hi. So does this scenario only work if we have one AI running the whole world, or could it work in a multipolar scenario?
Yes, the assumption here and the approach that I would advocate is that actually the first class agents in the world would all, and I would hope, all be human, acquire proof of humanity, and they have the optionality. We may not get it, but that would be what I would hope for. And then humans can delegate any part of their optionality, if they're whatever decision-making tasks they want, to whatever forms of AI or control system, whatever loops they want to, or to other humans. You can delegate it anyway, but they don't delegate away their responsibility. So human beings have first-class agency. You can have any sort of agent, but that agent can only operate upon the real world to the extent that human beings delegate authority to it. And also collective intelligence is made up of human beings in the same way, corporations, nation states, whatever. The ultimate decision-making is being made by individual humans to which that collective intelligence is delegated authority, but traceable all the way in every case to each decision is made by a person, and that you can be held legally and morally responsible, but they can use whatever AI tools they want.
I have two questions. Question number one, are we inside the model?
No, we're not.
Okay, good. So can you say a little more about, I think you kind of partially addressed this, but so the model sort of and an optimizer come up with a set of moves that are where the moves are made by mostly human actors in the world, and but it's kind of, I guess it is up to those agents whether they execute those moves or not. Or is there sort of an enforcement mechanism, global world government that does that, or does the game theory essentially tell you that provably over time, even independently acting agents that get these kinds of recommendations find it beneficial to converge upon, like, following the model's recommendations?
Right. So the system will do more than recommend, but less than act autonomously unless you choose to delegate it in that way. Each human being will be able to delegate as much or little authority to the systems that they have. So assume for the moment, just to simplify the discussion, that all of our information sources are networked accessed, and all of the optionality that we can execute, whether it's sending orders to the military or whatever, but it's via sending commands to networked assets of some kind that you have. So you have read access, in effect, to various information sources, read-write access to various things that you can control. You can stick in a control loop of whatever kind you want. It doesn't need to be automated at all. We will provide the facilities. If you want to do model-based predictive control, hook into the world model. Also, if you dislike or distrust some parts of sort of our default world model, you can swap it out. You want to use ESA's model of how the planets go around versus NASA's, you can do that. You want to use one, so there is a complex of models. So yes, in a sense, it's a shared model, but it's a model of a agglomeration of composable models. So they'll be vetted, they can be controlled, and we'll have default settings that will be based on best. You can change whatever you want. Be completely transparent. There'll be traceability. You'll be able to see the tests, the verification, validation that was done. You can see who the sources were.
So in terms of what this is currently being used for, my understanding is that it's often used for control problems in, like, a chemical plant or something like that.
Yes, and also it's used, I'm sorry, thank you. It's a lot of this the early development work, as I mentioned, I've got working software that prototypes most of the functionality that I'm talking about for this larger scale thing. And so most of this was developed by myself and colleagues at my current company and a couple previous companies to do model-based engineering for complex heterogeneous systems, mostly military systems, and especially laser weapon systems. I developed a tool which became sort of the de facto standard for doing model-based engineering for laser weapon systems. But it's much more general.
Great, thank you so much. That was our last presentation.
Okay.